Okay, the domain name system uses a hierarchical system to store the name database. Okay, this means that all the records are not stored in a single DNS server. Okay, it's stored in multiple DNS servers in a hierarchical manner. Okay, so in this example, we have three levels. The root DNS server will contain the record of the .com, .org, .edu, .ag, and so on, the top level domain. Okay, so he will know where to find all the top level domain servers. Okay, where are the location of the top level domain server? Okay, so these are the top level domain server, and inside the top level domain server, you contain all the records for the secondary levels. It means they know where to find yahoo.com, cn.com, company.com inside the .com top level domains. So the .org will also contain the records for the secondary levels for all of the DNS server that ends with .org and so on. Okay, and then in the third level, you contain, for example, companyaa.com. Okay, so companyaa.com DNS server will contain all the records for the servers inside companyaa.com. For example, www.companyaa.com, mail.companyaa.com, and so on. So as mentioned in the earlier slides, the root DNS server will contain the records of all the top level domain servers. Okay, so the top level domain server will contain records on how to go to the secondary level domain server and so on. So you are familiar with some of the top level domain, for example, .com, .org, .edu, and .sg. This will be your country code top level domain. Okay, now let's look at how a client gets the IP address of a particular website. Okay, for example, if someone wants to go to the email server mail.company.com. Okay, so what the client will do is, okay, they will query the .com, okay, the top level. Okay, the .com will check his record and he said, hey, I do not know how to go to mail.company.com, but I know where is .com, where is the .com DNS server. So you will redirect the request to the .com DNS server. So the .com DNS server will check, and same thing, he do not know how to go to mail.company.com, but he know how to go to the company.com DNS server. And the location of the company.com DNS server is here. And when the client query the company.com, they will return the answer of mail.company.com with the IP address of this server back to the DNS client. So the query is done in a hierarchical manner, okay, so that the records are distributed, okay, not consolidated inside a single server. Okay, next we look at DNS caching. So when the client makes a query, okay, the local DNS server will look at its own record to see if it can resolve the domain name. Okay, for example, right now, let's say you are in SP and you make a query to go to www.facebook.com. So you send a query to the local SP DNS server. Okay, so when the local SP DNS server receives your query, he realizes he can't resolve the domain name. He will try to contact the other server to help to resolve the name. So he will go through the earlier process, contact.com followed by facebook.com, and then facebook.com will return the IP address of www.facebook.com. Okay, once the match is found, you will return your answer, the answer that you in your query back to you. Okay. And the server will actually store the address in its cache. Okay. And in case a match cannot be found, that means there's no, for example, you type wrongly www.facebook.com instead of www, you only type 2w. Okay, then the DNS server will return an error saying that the name does not exist. Okay, so let's say use the example that if the match is found. So the IP address of facebook.com will actually be stored inside the cache of the SP DNS server. Okay, let's say your friend who come after you to class and also go to www.facebook.com. Okay, so he is also connected to the SP DNS server. So he sent a query back to the DNS server again, asking for the same website, www.sp.edu.sg. Okay, because the answer had already been cached. Okay, it was cached because earlier you yourself have sent a query, and then the answer was cached. So when your friend sent a second query to the same website, www.facebook.com, the SPDNS server realized that I do not need to ask again because I have already the answer cached inside my server. Okay, so the SPDNS server can immediately reply back to your friend on the IP address of facebook.com. So caching helps to reduce the DNS query traffic and the workload. Okay, imagine 10, 20, hundrds of SP users. They all go to www.facebook.com. Okay, instead of the SP local DNS server go and ask 100 times on the IP address, he stored the answer inside the cache, so he don't have to ask again and again. So what he need to do is just to reply back the answer using the cache. So this helps to reduce the query traffic and the workload. Okay, your computer itself also have a cache. Meaning, let's say now you go to facebook.com, you ask the SPDNS server, the SPDNS server reply you with the answer, the IP address of facebook.com. Then after that, you close your browser, you go and do something else. Then maybe 1 hour later, you decide to go back to www.facebook.com. Then your local Windows operating system will in fact store a cache, okay, of the IP address of facebook.com so that your computer don't have to ask the SPDNS server again. So your own computer also have a cache. Okay, all this will also help to reduce the amount of DNS query. Okay, so if you want to look at your cache, you can run ipconfig/display DNS. Okay, the cache is stored when your computer is powered on. Once your computer is powered off and powered on again, or your computer is rebooted, the cache is gone. So when you want to go to www.facebook.com, you got to ask the local DNS server again. Okay, let's look at domain name. So obviously all the domain name need to be unique. There can only be one www.sp.edu.xg. There can only be one www.facebook.com. Okay, there can't be two servers sharing the same domain name. So the ICANN, the Internet Authority, enforce the uniqueness of domain name across the internet. So when you want to have your domain name, you need to do domain registration inside a database. If the domain has already been registered, you cannot register it. Okay, so this is to ensure it's unique. So this database is also known as a Whois database. If you want to know whether a domain has been registered, you can go to this website. It will show you whether the domain name has been registered or not, in case you want to set up your own company. Okay, the registration is also done in a hierarchical manner. That means I can actually delegate this authority to the lower level, especially the country code. So for example, in Singapore, if you want to register anything that ends with .sg, okay, the SGNIC, Singapore Network Information Center, okay, is responsible for the administration of domain namespace that ends with .sg. So this SGNIC is inside IDA, or right now it's called IMDA. Okay, it was appointed the national registry responsible for anything that ends with .sg. Okay, currently the .sg domain have 9 extensions. Anything that ends in .sg, .com.sg, .org.sg, edu.sg, gov.sg, net.sg, per.sg. We go have the Singapore in Chinese and also in Tamil. Okay, so let's say when you want to set up your own company, what do? You have to register your domain name, and there's a list of registrar that you can actually do that. You can go to the different registrar to register your domain name. You want to look at the list of registrar that have been accredited by SGNIC. Okay, you can go and visit this website. This will show you the list of accredited registrars, so that when you want to set your own company, you can go proceed there to register your company that ends with .sg domain. Okay, that's all for chapter 6. If you have any question regarding DNS, you can ask me during the next lesson, or you can email to me.